Good afternoon, ladies and gentlemen. This lunchtime here at day 2 of 13th Cloud Expo. Good morning, good afternoon, good evening if you're following this lunchtime keynote out there on the World Wide Web at some curious time or place in space. Our next keynoter, our next exciting keynoter, because we've never heard him speak before at a Cloud Expo, and debut for Tim Knudsen, Senior Director of Biz Dev at Akamai. Our lifelong supporters, I want to say, but maybe only the last 13 shows. Let's give it up, please, for, and remember, they have paid for your lunch, so this better be thunderous. Tim Knudsen, please take it away on application delivery in the cloud.
Thank you. I appreciate that rousing welcome and even more rousing lead-in music. Couldn't have picked that any better myself. So everyone, please get settled as you're pulling together your lunches. I see also that magically my time has just shrunk by 5 minutes, so I'll be even more to the point. Like, you just keep throwing things at me here. Today, I'm going to talk about cloud delivery strategies in this era that we're in today. And with this presentation, I'll be covering a variety of topics. But let's get right into it, make sure we're all functional here. So we're in this hyper-connected world, and trust me, I'm not here to convince you that we're in a hyper-connected world. I'm here to talk more about, as you think about what you're building in the cloud, whether it be the apps, the services, you name it, what you should consider when it comes to delivery of that in this cloud era that we're in right now. So to begin with, a little bit of data for background to set the stage for some of the challenges and dynamics. And a lot of this data that we're sharing with you is stuff that's data that's publicly available, but also data that we have access to because of the fact that on a daily basis we see between 15 to 30% of the web traffic over the Akamai platform. So to start with, what's great is we're seeing a growth in global internet users. That's fantastic, rising up to 2.4 billion, one of the recent stats that we've found. With that, you have more devices, 4x now, from 2 to 8. So we're typically seeing, average 2 or more per individual. That aligns very well to what I have. Then on top of that, we're seeing more spend in commerce. Fantastic. Everything's trending up in the right direction. But when we think about the core of what we're talking about today, and that is how to think about strategies for delivering in the cloud, let's get to some more interesting statistics when it comes to some of the realities, which is this is a stat on the amount of IP traffic on a monthly basis. This has grown from 6 exabytes up to 43, so over 7x. So you're seeing a growth, a 2x growth in users, 4x growth devices, but look at the magnitude of growth when it comes to the data. That's because we're all looking to provide that rich, compelling user experience across any number of things that we're trying to deliver over the cloud, whether it be a banking experience, car buying experience, you name it. Now, these are all great things. It just shows how there's an upward trajectory, there's just growth, there's the tide is rising around us. But with the good also comes the bad, which is you have an increase in users, they're using more devices, and there's an increase in opportunity. There's also increase in the bad guys and the bad activities. Attacks are rampant. You can read all about them. I don't need to explain them to you. But what's important to consider is the size, the type, and the magnitude. They were ranging now. Before, where they were a big attack was 1 gig. We're now seeing attacks, and you're hearing about attacks in 10 gig plus range. So can this growth continue? Well, we can all sit here and speculate about all the different stats and project based on our models, the number of internet users, connected devices, the spend, global IP traffic, attack size. But really, we don't need to focus on what's going to happen in 2017 because there's enough of a challenge and enough of things to consider today when it comes about delivering apps in the cloud or services in the cloud and the strategies that you should consider. So with that, let's talk a bit about how to think about that. So while it may appear so simple as a consumer, of these services in the cloud, because one of the great things is the cloud has simplified a way of building apps, delivering services. We all have our smart devices. We all are able to consume services very easily. With utility computing, even standing up things is even easier than ever. Unfortunately, as much as it appears to be simple from the outside, it's far from simple on the inside. And it's also quite problematic. If you think about all the compounding factors for which this is just a subset of the list, if you wanted to create the Uber list, you're talking about dealing with data centers that are in multiple geographic locations. You're talking about a multitude of different types of networks that are connecting the data centers to the end users. Are you talking about public clouds? You're talking about private clouds. We're talking about shared infrastructure, non-shared infrastructure. The networking arrangements between the end user, from where the end user starts to where the data center is. Carrier networks, you have the carrier mobile networks. All these factors come into play into the different situations that are being faced by the end user when they're trying to connect to whatever service that you're offering. Compounding that is then, if you think about the device layer and the presentation layer. Most of us have one, some of us have many different devices. Each of those devices have different operating system versions, maybe running different versions of the browser. Some devices have multiple versions of a browser. I actually run three different browsers on my iPhone for a variety of reasons. You have different media formats. You have different connection types, different throughput, and that will actually vary based on, it could be the same user, same device, same browser, but different connection types, different throughput for that as you move around in different parts of San Francisco. So all these things need to be part of the consideration when you think about the strategy for how you want to build your delivery of your service. So, and the main theme here to consider is, again, going back to when you look at the key thing you want to drive towards, which we're all aligned on, is how do we get to that user experience, right? The seamless, rich, clean user experience. But now, more than ever, with the variety of devices, the variety of connection types, and the multitude of options of standing up an application and service, you really got to think about the different types of situations in which you want to optimize for when you are building and deploying these services. And not only is it a situation from a user experience standpoint, but the situation also from a protection standpoint when it comes to security. So one way to frame this, when you think about what to consider, is the three buckets. You got your cloud bucket, your mobility bucket, and your security bucket. And I'll go into each one of these areas to talk a little more about specific things to put on the list when it comes to looking at how to deal with the different situations that you'll be facing or your end users will be facing as they access across your services across a variety of different devices. So first, let's dive into the cloud bucket. So what are some of the key challenges with cloud performance? Well, you got your end user, who's always conveniently situated on the right, and you have your data centers always conveniently situated on the left. But what you'll find is if you actually were to diagram out how the user, when they make the request to view the page, to get access to the listing, to view their account, whatever it might be, that path is anything but straightforward. And the reason for that is just the way that the internet is built and how traffic is routed from an end user coming out on their ISP or that Wi-Fi or however they may be connecting to the data center. And that data center could be public, it could be private, you name it. The other challenge here is, of course, the inherent challenge of how the protocols work. Round trips for a typical page is 31 is what we've measured and benchmarked across a variety of different industry profiles, from online banking to insurance to travel to retail. This can grow far greater when it comes to the richer type of experience you're delivering with the page, whether it be viewed on a mobile device or a desktop browser. So each time what happens there is the multiplier effect. Which obviously results in decreased performance. So one way to consider how to combat this is There we go. Very good. Is how to break down what's happening. I think we have a slight battery issue here. Across between in the cloud, between the end user and where that data infrastructure is sitting in the cloud. So one way to think about it is you break down the first mile, the last mile, and what's happening in the middle mile. So what we found is that the challenges are not typically sitting in the first mile or in the last mile. That's where you have abundance of connectivity in many cases, with the exception of the mobile use cases and scenarios. But that's not really where the bottleneck lies. Where the bottleneck lies when it comes to this round-trip multiplier effect is in the middle mile, and that is across that multitude or myriad of different networks and peering arrangements for which the packets are getting routed as they go across BGP from end-user client to the data center and back again. So as you can see this diagram here, looking at an example where you have the middle mile being 8 seconds, but in the case of the first mile versus the last mile, they're quite negligible compared to that. So if you take your 31 round trips across that back and forth, you get to an 8.4 second response time, which in our era where we look at desktop response times in 2 seconds, that's 4x and very much into the unacceptable and intolerable range. But if you think about how to combat that, that's where you want to start looking at optimization techniques that leverage a presence in the cloud, that look at how that then provide a way of optimizing against these inherent bottlenecks in the protocols, both the routing across BGP by finding a smarter path, one that doesn't have congestion or one that has lower latency. Looking at the TCP behaviors themselves, which is just basically how the data is moving back and forth, being able to maximize the amount of data throughput. Then all the way up to the application layer, which is the HTTP, and applying techniques to be able to pull the content forward as close to the end user or to the eyeballs, so that the response time from the browser is greatly reduced, because the browser thinks the content and the application is very, very close because it's been distributed or pushed to the edge for the end user. So optimizing protocols can take that technique of protocol optimization and looking at this from the bottom up can help shave off a tremendous amount of the response time issue, taking it from 31 round trips to 5 and taking that response time all the way down to sub 2 seconds. Now, it's more than just performance, though, and we'll get to some of the other issues. But when you think about the global distribution of your end users, you need to think beyond just performance and taking that, for example, 59 seconds down to 15 in Asia across a multi-step process. You also need to think about how you can do this in a very rapid way, much like the cloud's promise is, and that is, how can you apply optimization to remove the bottlenecks, but how you can turn up optimization on your services in a near instant way, much like this diagram shows here, which is moving from an unacceptable over 10-second response time for a specific page in a portal and bringing it down to sub 2 second by immediately optimizing against those bottlenecks. Why this instant on element is important to consider is because you want to be able to stand up your performance as quickly as you're able to stand up your application. Now, in addition to this, here we go. You also go beyond performance to think about reliability. We've all seen the headlines around the outages. They range in size and magnitude and frequency, but as enabling a business and providing business services via the cloud is something you have to architect to think about. How do you handle this situation, and what are the technologies that you want to implement to protect against this? One thing to consider here is, again, your data center could be anywhere depending on which cloud infrastructure you're using or which you pin it to, and there could be multiple of them. So if one becomes unavailable, obviously there's failover inherently built into these data center infrastructures and their fabric. But what else can you do to think about that problem from the outside in? And that's where looking at control, or being able to leverage techniques like global traffic management, whether on a cookie or other basis, can come into play as part of your delivery strategy to ensure uptime and reliability, in addition to the performance you've already ensured across all the different network conditions that may be facing your end users, because you don't have specific control of where these users may be, nor the networks that they're going to be crossing. They're not sitting in a fixed branch location. And we have to think about that extra layer of agility when it comes to being able to protect against availability. So, but it even goes further than that. If you think about many of you sitting in this room today, you're probably thinking, yes, I have a desktop presence, a desktop experience I need to think about. I have a mobile experience I have to think about. But what is this guy putting a branch experience up on the screen for? Well, what about the branch? If you think about how many of you have been into, show of hands, have been shopping recently in some more larger known retail brands such as Nordstrom's or Williams-Sonoma or some of those outlets on the weekend picking up the to-dos. You'll notice something different now. You'll notice a lot of people walking around with tablets assisting you in your buying experience. These tablets are loading up applications that oftentimes have this really great way of pulling up a high-res image of that product that you didn't think you needed to buy 30 seconds ago, but boy, it might look appealing now. This is all part of the omni-channel experience that a lot of companies are driving towards. It's prevalent in retail, but it also extends across other verticals as well. What's the challenge here, though, is when you think about delivering into the branch, is how is the branch connecting to these applications? Some of these apps are still over the internet. A lot of these apps are finding their ways being built on the cloud. And so what you have is a situation where is the inverse of what you think would be the case. You'd almost think that oftentimes the residential access would have less throughput and performance than what you'd get that would be available in a branch. It's actually quite the inverse. The branch has commonly commonly thin pipes and has challenges with overall size of the connectivity going into the branch, which then results in a number of factors. One is the available throughput going into it, but also how the branch network is architected. And oftentimes, in today's world, direct-to-net connectivity from a branch out is not commonplace. What's more commonplace is what's described here by Gartner's trombone effect, which is backhauled traffic that goes from the branch back to the data center or to multiple data center and gateway points, then out to a cloud infrastructure, whether it be an app that's built on an IaaS platform or it could be a packaged SaaS application, but all the way back in again. And so that's where you're getting these examples of 16 hops versus 5 hops for using these services. The end result is that you're seeing data like this, where what this chart shows is that you have, the blue line represents the latency, and the throughput, and the orange dot represents the latency. And what you don't want is what's happening on the left-hand side, and that is where you have a high degree of latency that's impairing significantly the download speed. So go back to my earlier example, high-res image, trying to capitalize on that impulse buy situation. You want that image to come up snappy, quick, so you can talk about why this makes sense to pull the trigger via right here on the spot in the aisle. And oh, by the way, I can service that transaction via my tablet that I have in my hands right now. So the branch becomes yet another area to factor into how your delivery strategy needs to be architected for. And it only gets more interesting when you think about the variety of different services that are being brought into the branch to create this rich experience. You have point of commerce, which is the example I just illustrated with the compulsive buy example of the high-res handbag. But it goes beyond that. You have digital displays. You have the idea of endless inventory with kiosks. You have online training, video content coming in. And the list will continue to grow. But the point here is not the lists. The point is what you can do about solving this problem. And there's a similar technique that we talked about before that can also apply here to be able to take that gray line, which is what you want to avoid, which is a very painful experience, down to the orange line, which is a very workable, good experience that you want to bring to your associates, to your employees, and to the customers that they're serving. And the way to think about getting that is take some of the same ideas before that are being applied towards the mobile user or the unfixed desktop user and bring that directly into the branch architecture, leveraging existing network platforms such as the Cisco ISR that now offering capabilities of bringing an enriched experience in the store, leveraging the caching and other technologies to support improved web response times. So that's how to think about performance from just the protocol optimization level all the way down to your unfixed mobile arbitrary users down into the branch. Now, what about mobility? So mobility is key. I don't need to spend a lot of time talking about how important mobile is. Let's talk about what you need to consider. So what do mobile users want? You can find a variety of different reports. But what's really interesting about some of the data that we've uncovered, is there like a manual button I need to push? There we go. is this, which is they want to be able to purchase, they want product information, and, oh, by the way, they want sites loading in 5 seconds or less. Seems reasonable, but hold on a second, 5 seconds. I was just talking about 2 seconds, and you can read a lot of reports about the 2-second rule and conversion and experience. Well, if you look at the state of the mobile situation, and you compare it to the desktop situation, and you look at a cross-section, for example, that's provided by the Keynote Commerce Index, the top 30 desktop sites load in 2 seconds or less. The top 30 mobile commerce sites load in 9. 9 seconds, more than 4x. 9 seconds was so 2001. We haven't seen that metric as being a benchmark in 12 plus years. So and with mobile being so important as part of an omni-channel experience, or part of a reach or channel to your end customers, what can you do about this? So again, going back to the different situations of what to consider, you have the matrix. If you want to put it in a testing context, the matrix of considerations becomes a bit large. What device? What version of the device? What browser? What version of the browser? What network? What latencies are you dealing with? IPv4, IPv6, and probably more, and then even more importantly or not, as you start to go down the list, you get into things like, what is the experience you're delivering based on how personalized it is? What are the actual additional API calls you're trying to load when the user gets to that particular point in the process of that page? Because all of that starts to add up when it comes to what you have to consider when it comes to delivering that performance for that mobile device. So the way to approach this is, one way is, of course, to attack it with the protocol optimizations we talked about earlier. And if you want to put this in illustrative terms, think about that as, you've all seen the waterfall chart. So think about that as taking your 4-second view as an example and pulling in the time for each one of those objects to load. So 4 seconds goes down to 2 seconds. You're basically shortening the length. Then on top of that, there's 2 other things you can do. The next thing you can do for part 1 of that is you can look at what you can actually do to the content and how the browser is loading the content itself. So techniques like front-end optimization, which now applies, think of it as a compaction on top of the shortening of the response time. So you're able to move from the 2 seconds and then cut that further in half. Because now, as you can see by the number of lines or rows, the amount of content the browser is having to interact with, or objects, is now gone down as part of this compaction and optimization technique. The other thing you can consider is what to do with the actual content itself. And that is, be able to intelligently and dynamically adapt against the different situations for which the end users are trying to access and use whatever services you're making available to them. So here's some examples of on the right-hand side of looking at a particular image, and we all want to deliver a rich experience, but we have to consider how rich we make that experience based on the situation of how the user is connecting. It may range from excellent connectivity, all bars and a Verizon LTE, to very poor connection activity, which is my favorite. When I see on my phone it says Verizon 1X, or Verizon with just a single 0 next to it, which I'm never quite sure what that means, other than I may not connect at all when it comes to my data service. But the point is, the other dimension of optimization besides compacting is now looking at how to dynamically optimize this image down to a size that is more suitable for the throughput that that user's device can support based on the situation of how it's connecting. So at the end of the day, if you want to put some goals around this and how to think about this is, you look at this chart right now. This chart shows a distribution of response times starting from the left from 1 second all the way to 15 plus seconds, which I don't think any of us in this room would even really tolerate at the end of the day, and maps that against the axis of percentage of users. What you want to be able to do as you think about what techniques to employ is take this chart and be able to provide an overlay much like you see here, which is move those users to the left. You want the majority of the users, as like you see here in this test data, to be sitting in the 5, 4 seconds and less response time, because that's the experience sweet spot that you want to target to deliver that compelling experience for your mobile users. So let's move on to the final bucket, security. So security is something that is top of mind, obviously, hopefully, but a very interesting situation, one which we have a pretty interesting insight into based again on the fact that we have this global overlay network and we see 15 to 30% of the web traffic on a daily basis. What we're seeing is, just to share with you, is the magnitude and the complexity and the frequency growing and growing and growing. And what should you do about that? What can you do about that? Like 74, these stats, as much as they've been refreshed recently, are probably already out of date when it comes to what's happening in the landscape of security and the threats. 74% of companies experience one or more cyber attacks in the past year. These are, in 31% of the cases, they're resulting in service disruption, typically due to a blunt distributed denial of service attack, which is easy to recruit a number of actors to participate in for a variety of reasons, for both bad or what some people may classify as acceptable if it's around political hacktivism. The costs, they'll vary, of course, based on what your business is all about, but they're non-trivial. What's really starting to get interesting and alarming is the size. We used to talk about 1 gigabit per second, and then we talk about big attacks at 10 gigabits per second. Now we're saying smaller average typical attacks are around 10 gigabits per second, and multiply that by 10 to get to the large attacks, which are 100. And I bet if I do the same presentation a quarter from now, that bar will probably be even higher. Then look on the right-hand side. The frequency continues to grow. Just from 2009, there were 14 in that range. Now, in 2012, approaching 800. It's happening frequently, and it's happening from all over the place. If you've got a few minutes, go check out some of the stats that we offer freely off of our website on the state of the internet. And you can see the origination of these attacks and how it's shifting on a basis of time from different parts of the world, and oftentimes parts of the world you wouldn't expect to be the origination of so many attacks. Oftentimes, it's within this country itself. What's also eye-opening is the variety and sophistication. On one hand, it's not totally a shock that SQL injection is the most common, followed by DDoS. But it's really how these are being nuanced to try to thwart what are perceived to be, common methods of defense that are being employed out there. And that's really what I want to talk about next, which is, there's the way that you could traditionally have thought about defense, and there's other ways that you can think about defense moving forward. Commonly, there's been an approach that's in the past, and I'll emphasize the past because I know things have, with the amount of attacks, have changed quite rapidly in recent times, is that there was this kind of a single perimeter or single layer of defense type of approach. And the challenge with that is, you're now trying to block a lot of many techniques. We're relying on blocking that attack, whether it be distributed denial of service, or SQL injection, applying a perimeter defense all the way in at the data center. So effectively, the attacks would be getting to the data center, and you'd be trying to block them there. And that's, while that is a method of protection, the challenge is that you've effectively let the bad guys you've brought them all the way to your front door. Right, and oftentimes what happens there is, even as much as you're applying techniques to block traffic, a lot of that traffic's already at the front door. So you're now starving resources, or maybe your neighbor is under attack. So if you're on shared infrastructure, you have a noisy neighbor problem. So you got to think a little bit beyond that. You got to think about multiple layers. So another way to think about it in terms of protection techniques is, which has also gained a lot of traction recently, is to think about multiple layers of defense. A lot of folks like to use the terms belt and suspenders. There are others. The whole point is putting multiple perimeters in place. And one perimeter that's important to put in place is putting a perimeter into the cloud itself, leveraging cloud DDoS and cloud WAF capabilities so that you can protect the origin before, or at least mitigate or thwart a lot of the attack traffic before it even gets to the origin itself where the application is, and be able to maintain services even under attack. So the way that works, just to put a picture around that, is if you look at here, you have all of your green users, which illustrate the good guys. And they're going through a cloud-based overlay network that provides also DDoS protection and WAF capabilities. And with that, in a scenario where there is an attack, where the bad guys come in, what this overlay does is provides basically a shock absorber against in the case of a DDoS attack, the brunt of the attack, but also with the WAF capabilities allows you to also add a layer of precision when it comes to other types of rules that you want to apply to the traffic to block. It could be on IP basis, it could be on a rate limiting basis, or it could be other type of specific content that you want to inspect and block on based on the characteristics of the attack itself. Now, of course, what the challenge here is that the attacks are morphing. They may be morphing across, and they may be morphing within attacks. So you also need to consider techniques here that allow you to update and make changes to the policies so you can apply this perimeter protection on an ongoing and changing basis as well. But the key point here is that by applying it out at the edge, you're able to maintain the operations of the services you're offering in the app, based on the apps you're providing, because you're not allowing the bad guys or the bulk of the bad guys to get to the origin, because it's being blocked at the edge. So just to give you a sense of what we've seen based on our own experience in being that perimeter in the cloud, being that providing the cloud DDoS and providing the cloud WAF capabilities, is some of the data we collected in the 2012 Olympics. So we can't share all the sites that we protected, but in aggregate, some pretty interesting metrics that really illustrate some of the points we've been talking about. One is types of different requests that were denied. 23 different types of requests were denied based on a variety of different attack methods. Based on all the rules that we employed across these different sites, we triggered 25 million rules. I mean, in other words, 25 million rules fired. We didn't have 25 million unique rules, but we had, in the aggregate, 25 million times the rules fired. Just to give you a sense of how often this was going off. And what we also observed is, when baselined against previous traffic profiles, the amount of attacks that these sites were enduring or seeing resulted in 40x the normal traffic. So while you may not hear about every single story, the point here is it's happening all the time, and it's happening in varying magnitudes. And also at different points of the infrastructure. So the example I showed you earlier was this idea of being able to block, at an HTTP or application layer, the DOS attack and some of the other precision attacks that a WAF can defend against. Another point of vulnerability that you need to consider how to protect against is DNS. We saw, it was interesting to watch the strategies morph as we saw folks going after, just blunt DDoS attacks, then shifting into blunt DNS attacks. This is an example here of a bank where we saw over a period of 4.5 hours, the attack traffic was 10,000x the normal. And those are the amount of DNS queries that we were handling as the attackers were pointing the thrust of the volume at the DNS infrastructure. And so therefore, being able to have a distributed DNS protection is also important when you think about the different points of how you want to protect against losing service operations and availability. And I think last but not least, another example of a bank, which banks are oftentimes targets, is looking at the peak traffic metrics that we have here, which is at the peak of the attack, there were 4 million requests per minute coming in. And here's where, as they were coming in, the IPs, this is not a new technique, but one that is still employed, constantly changing, and we were constantly updating and blocking new IPs. So at the end of the day, we blocked over 1,700 new IP addresses that were introduced as part of this attack. The key takeaway here is that while performance is part of the experience equation, availability is part of the experience equation are very important. You have to think about also how that factors into the different situations that your end users will be accessing your services. Part of the experience also is just having the service up, and that may not be a function of the infrastructure's availability inherently or the performance, but some other action being taken on the origin or the application in the cloud based on some type of attack, both directly on you or maybe one of your neighbors that's sitting in the same pod or infrastructure. And so when you think about your delivery strategy, you got to think about the spectrum, including security as part of that. So in terms of key takeaways, a couple key reminders before I wrap up here. First of all, the complexities, you're aware of them. I don't need to remind you that they're there. But think about the breadth of the complexities and really zero in on the ones that are the highest priority as it relates to who you're targeting and the services you want to enable to those folks you're targeting. And you got to think about that across from a cloud perspective, a mobile perspective, as well as a security perspective. Not being able to have a delivery strategy against those will hamper adoption. That may translate into revenue, it may translate into productivity, it may translate into brand recognition, shopper loyalty, whatever it may be. But those three, we feel, are important considerations when you think about what are your business goals, what you're trying to do. And the other thing to keep in mind, too, is constantly think about how things are changing as the cloud era continues to evolve and grow, and how that should then be refactored into your strategy across those areas. It's a dynamically changing environment. Your situations you may be planning for today may be situations that you don't have to worry about in the future. But constantly think about how you want to refresh. You need to have a constant refresh on what you need to consider when it comes to your delivery strategy across the situations that you are delivering to. So with that said, I have landed with 2 minutes left of my time. You hopefully all had a good lunch on us. Thanks for joining. And if you have any questions about delivery strategies and what it is that we can help you with, or just questions in general, feel free to visit us at booth 208.
That sounds like quite the invitation, but not before thanking, in the time-modern fashion, Akamai for the lunch. Oh, I can't speak now. For the lunch that was supposed to be.